So let's have a look here at question 8. If you look at the bottom right of your screen, you'll know that B has been highlighted. That's because the course report in 2023 identified that most candidates found Part B tricky. So we're going to have a go at answering the whole question this evening. So before I even look at what's on the right of the screen, let's look at the stem of the question. So we have got a number matching game stores 4 winning numbers and compares them to the player input of 4 numbers. Sorry, my webcam is doing weird stuff, so I'm going to disconnect it out the back of the computer. I think it's one of those two. We're looking at essentially matching the numbers that the user inputs with 4 winning numbers, because we get points. It sounds like a bit like a lottery, to be essential. And the more numbers we match, the more points we get. So if we match 2, we get 500. If we match 3, we get 750. But we are told that there is an error in the program, as we always get 1,000 points. So this question looks like it's going to be set up in a way to help us to work out why there is an error. So we've got some code, and we can just fairly straightforward code here. We have got an array called winning numbers. We've got an array called num matches. We're getting the 4 numbers from the user, and then we have a fixed loop that works out if the number in the array matches any of the numbers that we have inputted, and if it does match, we count it. So that's kind of our count occurrence, but 4-way, and then we output it. So we are putting a breakpoint on line 26. Okay, so I suppose before we go any further with this question, we've been told that there is a breakpoint. What is the definition of a breakpoint? So let's work out what is going to happen to index, winning number, and matches. So we're told initially that index is 0 because we're in our loop. So what therefore is at winning numbers index? What's the value of winning numbers index? So our winning, we can say that winning number is 0. Winning numbers is cleared up here, and the one at position 0 is 10. So that is going to be 10. And what we're looking for is we're looking to see each of the numbers if they match 10. Okay, so do any of these numbers match 10? Yes, they do. So we get at least one match. Okay. So, and again, when you go into the exam, you can doodle all over the question. Okay, the only bit the marker wants to see is the actual question. So if you want to doodle, you can doodle. Okay, so we're now on index 2. So we're looking for winning numbers, index 2, which is 14. Okay, so does number 1 match 14? No, because that's 5. Does number 2 match 14? No, it doesn't. Does number 3 match 14? No, it doesn't. So therefore, I'm going to add... Oh, that went really offline. So therefore, number 1 doesn't match, number 2 doesn't match, and number 3 doesn't match. So I'm going to go into the else portion of the if statement, which means I add 1 to my previous num matches, which I get means I get 2. And we said that was 14. Okay. So what I've done is I've gone through this loop twice, and based on the numbers 10 and 14, I have worked, or my program has worked out, that I have got 2 matches within my numbers, when in actual fact, I have got 0. Okay, so by iterating through this loop twice, we have identified a problem. Because we have identified that really, regardless of what the user has put in, okay, we will always get 4 matches. Okay, and that's what the next question is kind of want us to look for. Okay, with reference to the code, why will the number of matches always be 4? What are we thinking for that question? So if we look at this answer that we've got here, because if the number doesn't match the first 3 in an array, then 1 is always added anyway in the else statement. So the key bit there is the fact that we are touching upon the fact that there is an else which will always be executed. And you could always make that a wee bit better by saying line 24/25. And then we've actually here, this person has told us how we can correct the problem within the program. So definitely going to get the marks for that answer. 1 mark and lots of detail there. Okay, so let's go and have a look at question number 9. Now, in question 9 here, we are going to focus on kind of the knowledge questions about code 9b, 9c, and 9d, as opposed to the problem-solving ones. So, the context for 9b, c, and d isn't particularly important, but it is the idea that we're a dog grooming company. It has branches in Edinburgh, Glasgow, and Stirling. We store the ID, the name, branch that a dog attends, and the number of visits. We are told that one of the features is to offer a discount to customers that have visited Dundee and Stirling more than 4 times. That's more specifically for Part A. And then that we've got that the data is stored in 4 parallel arrays. So I think that's kind of quite key, because you might have looked at this question and gone, oh, I've got 4 pieces of information. It's an array of records. It's not. It's a parallel array. So let's go through these fairly quickly, see if we can go through them quick fire style. So, formal and actual parameters are used in this code. So can you, into the chat, give me 1 formal parameter and its associated actual parameter? So in one post, can you give me the formal and its associated actual parameter? So if we're thinking about what a formal parameter is, a formal parameter is used when the function is or procedure is declared, and the actual parameter is passed in when the function is called. So if we're looking at, really good answers, if we're looking at formal parameters, our formal parameters are pet number, city, and visits. And if we're looking at actual parameters, they are dog ID, branch, number of visits. And if we want to match them up, well, pet number is dog ID. I'll go for that one. City is branch. And hot pink. Visits is number of visits. So you could have any of those pairings to get you the 2 marks there. Okay. Because that gives us our formal and our associated actual parameters. So let's have a look at part C there. Okay. Describe the operation on line 24 during the execution of the program. Okay. So we are looking at specifically line 24, which is down here. What are we doing on line 24? So what we are doing here on line 24 is we are calling the customer search procedure or subprogram or subroutine, whichever word you want to use, and we are passing in the actual parameters. Okay, so we need those two things to get the marks. Okay, the first mark is that we are to call the customer search subprogram and pass the parameters into this subprogram, okay, or subroutine or procedure. Okay, you get away with saying subroutine. You get away with saying subprogram. You get away with saying procedure, but you would not get away with saying function because it explicitly says that it is a procedure because it doesn't return a value. So moving on to part D, we're looking at the scope of variables. And the first question that we are asked to do is we are asked to identify a local variable. So we're looking within the function here to identify a local variable. What are we going for? So your local variables are your variables that are defined and used within your subprogram. So the first is the fact that we have got a counter, or a loop, sorry, that uses a counter of the value I. That is declared and used within that program. You can also say that any of your formal parameters, they are also local variables because they are defined within the function. Okay, so for this question, you could have had any four of those options. So you could have I, city, visits, and pet num. Any one of those would get you the 1 mark that this question here is worth. The next question is thinking about that local variable, with whichever one you have identified. What is the scope of that variable? Remembering that the scope of a variable refers to how much of the program essentially knows about that specific variable. And in this question, we're looking at specifically the variable that you have identified. Be specific, okay? So in this case, we could say that the scope of this variable is that it only exists within the customer search subroutine, or the scope of this variable is that it only exists on lines 1 to 7, although I'd put that into a sentence. Accessible across lines 1 to 7. Okay, any of those two would be totally acceptable. Okay, so that's us looked at question 8 and a bit of question 9. There is one wee last bit of question 9, 9DII, and you'll see again it has been highlighted in yellow because, again, course report, most candidates have found it challenging. So, explain why using local variables increases the maintainability of program code. So, what are we going for this question? Um, explain why local variables increase in the maintainability. I take this answer here, which is a good one. Other variables in different subprograms can use the same name because, again, the scope of them are only within that program. So, yep, we had a loop with I. The chances if another subprogram had a loop with I, the two of them won't class with each other. Yeah, again, that idea they only exist within the subprogram that they are in, so that we can edit them without affecting other variables and other part of the program. We've got an answer that touches upon testing. Errors are easily identified as they happen within the sub procedure. That probably would get the mark. We're also looking at the idea that you're relying less upon global variables because we want parameter passing, so they're likely to have fewer errors. But it's the idea that because it exists within a subprogram, it essentially means that that subprogram is more portable. Okay, conscious of time, and I do want to have a look at a bit of question 11 as requested. But I've also just spotted on the screen here this question 10. And we're not going to do the whole of question 10 this evening, but I want to just talk about that first part of question 10. Because when you generally look at course reports, the parts of course reports that candidates find most challenging is the analysis side. And it was pulled up in the 2024 one when we looked at it last week. The analysis question was pulled up, and again, it's been pulled up in 2023. So let's have a quick read of the context. A check digit is the number at the end of a series of characters that can confirm something is correct. A program is to be written to add a check digit to a user's password. The password is input, and then the program totals the ASCII values of all the characters, divides that total by 11, and calculates the remainder. The remainder is then attached to the original password as a check digit. For example, for the password Fox, we have got a kind of worked solution there. So we are asked what state 1 boundary of the program. So boundaries are something that some candidates find quite tricky, but we're thinking about a couple of things. What must the program do? What assumptions can we assume about what the program is going to do? And then what does the program not need to do? Okay, so what do you think might be a boundary? So we're focusing this question on the ASCII. So we're obviously thinking about how we're storing that data and the raw format of it. So one thing that we can say is that we only want ASCII values. Okay, so I'm not going to store, for example, a password that has a smiley face in it. Okay, because that is not stored as an ASCII value. Okay, there is also kind of assumption that if we're going to be doing this with passwords, then the password must be at least 1 character long. Okay, because if it's not 1 character long, then the program's not going to work. Okay, so those are kind of 2 possible boundaries that would work for this program. Okay, question B, we're not going to do question B tonight, but just to give you a sense of what this question is looking at. So we're using a design technique of our choice, designing algorithm that would create the updated password and store it in a file. So this question is definitely a problem-solving question, but it is assessing 3 different aspects of the course. Okay, 1, we're talking about ASCII. So it's looking at, well, how do you get a character to ASCII? Okay, it is wanting to take a word, for example, Fox, and get the first letter, get the second letter, so it's talking about substrings. Okay, it is doing a division and finding the remainder. So it's talking about modulus. Okay, it's actually covering 4 things because then we want to store it in a file. So this question is covering substrings, character to ASCII, modulus, and writing to files. Okay, those are the 4 things that this question here is covering. So it's quite a good question to go and have a go at, and then you can go to the SQA website and pick out the marking scheme and see how you do on it. Now, question 11, we had a look at a question very similar to it last week when we did the 2024 paper. So I'm going to kind of skip through bits of it whilst trying to give you some understanding of what we've done to get to the point where we're in the last part of it. Now, there is no doubt with questions like this, we were dealing with a record and an array of record, and we need to do something with it. It progressively gets trickier. So question 1, we stock washing machines. So we want to create a record that stores information about a single washing machine. Now, what I have noticed recently in more recent papers is the SQA are telling you what the name of the record structure must be. So in this case, we are told the name of the record structure must be feature. So in here, I've got my record structure, which is called feature. I've listed each of the fields, and I've identified the data type for my 2 marks. The next portion of the question, we are told that we have to declare the variable called machines. So again, we're told what this variable must be called. That is going to store 80 washing machines, and we're going to use the data structure from part I, which means we're going to use feature. Okay, I'm a Python person, so I'm creating an array. That should be an equals. I'm creating an array, and that array is going to contain 80 features. So for my 2 marks there, 1 for creating the array, 1 for using the record structure. We then get a data flow. Okay, and this data flow is worth 2 marks. And this is where this question begins to get tricky. We are given essentially a use case, an end user requirement that they ask how much is the cheapened washing machine that can do wash a load of 11 kilos or more and a spin speed of over 1500 RPM. That's what a customer would ask. So we've kind of got a top level design for this. We're reading the data in from file. We're asking the user for the smallest wash load and the smallest spin speed that they would be willing to go to. And we can see here that step 2 returns that. We then need to find the price of the cheapest washing machine, if there is one, that's key, that meets the entered requirements. Okay, so I've been told by the user what's the smallest wash load that they want, what's the lowest spin speed they want, and I need to find a washing machine that matches it. So in order to achieve step 3, I need to know the smallest wash, the slowest spin speed, and have all the details about the machines that we stock in our shop. My function is then going to output the cheapest price and the found. So in order to display the cheapest washing machine and the information, we need to put that information back in to the next function. Hopefully, whistle-stop tour of the question has helped you. So we move on to 11C. And 11C is, by all means, I don't think the question's tricky, I think it's the way it's added. So, step 3, find the price of the cheapest washing machine that meets the entered criteria. If there is not a washing machine that meets the criteria, then set found is set to false. Using a program language of your choice or a design technique, write the code for step 3. So that means we're looking for the price of we're looking to find the price of the cheapest washing machine that meets the entered criteria. So, my question here, people, what standard algorithms are we using? So if we work out which of our standard algorithms we are looking for, that could then help us write it. So, we can split it up. Let's get the highlighter on. We want to find the prices, okay, or we want to find washing machines that meet the entered criteria, okay. So that there, to me, is a linear search. Can't spell, can't write. It's a Monday at nearly 7 o'clock. So that's a linear search, okay. But we want to find the price of that washing machine, okay, which to me then says, well, actually, we also need to try and do a find min, okay. So we're going to design an algorithm that incorporates a linear search and a find min, okay. Let's do one of them, and then we can hodgepodge in the other one. So we'll start with the linear search. Okay. Now, you're welcome to have a go at this yourselves and work it out. I'm going to kind of talk you through how I would answer it, because it is quite a tricky question and I'm conscious of time. So, we need a variable called found, and we're going to set found to be false. Okay. We are then going to loop through, and I need to remember what the array was called. The array is called machines. So loop through machines with counter. Okay. I'm then going to see if I can find a washing machine that matches the smallest and slowest. Now, it's not a match. If I go all the way back up, it has to be or more or more. So I don't want an exact match. I want it to be equal to or greater than. So my array is called machines, so I need an array. It's got a value in it called, what did I call it? I called it max load. And I want that to be greater than or equal to the smallest wash, insert by loop user. And I want the machines counter dot spin speed to be greater than or equal to the slowest spin. Okay. If that if statement, that should be an if. If that if statement is true, what am I going to do? Well, I'm going to say, well, I've actually found a washing machine that matches. So I'm going to set found to be true. So there we have our linear search. Now see if that's all that you were able to write. Okay, you would get 1, 2, 3 or 4 marks. Okay. So even if you've just got half the question, you're getting half the marks. Okay. So we now need to think about, well, how do I integrate a find minimum in this? So we need to initialize a minimum price, okay, or cheapest price. Now, we would normally assume that the minimum price is the first item and work from there. However, because we have got the added criteria in, we can't. So we need to pick a really big number. Okay, chances of a washing machine ever costing that amount are minimum. Okay, we then need to do, if we think about our find min works, we loop, which we've got, and we've got an if statement that's looking to see if the current value is less than the stored minimum. So we just go and machines counter dot price less than the cheapest price. If it is less than the cheapest price, we are going to update the cheapest price to be the current price. And there we have integrated into that our find minimum. Okay. If when you started this, you started with the find min and then integrated in the linear search, again, you'd have got 2 or 3 of the marks out of 7. So again, it's trying to get as much marks as possible, breaking the question down in its component parts, looking for the standard algorithms, they're going to be there, and then fleshing it up from that. Now, admittedly, it's a lot easier for me typing it to add in bits of questions than it is you if you're writing it in the exam. But if you need to put arrows or stuff, you're probably going to be fine. Okay, now I'm conscious that we have not looked at databases or websites at all this evening. And we've really only got 10 minutes left. So let's have a look at question 3. Computer system question, data representation, floating point representation to be specific. You'll notice that our floating representation questions are 3 marks. And my ink's not working. The 3 marks are essentially 1 for sign bit, 1 for mantissa, 1 for exponent. So let's break this question down. What would be the sign bit for this question? Is the sign bit 1 or is the sign bit 0? So in this case, the sign bit is 1 because we have got a negative number. Congratulations, you have just got yourself 1 out of 3 marks. So the next step is working out, I probably leave the mantissa till the end, and I now do the exponent. So let's have a go at working out what the exponent is going to be. Let's quickly have a look at part B. State the effect of increasing the number of bits allocated to the mantissa. So we're looking at potentially, instead of having 16 bits, we have got more bits, 24, 32. What's the impact of having more bits for the mantissa? So when we're talking about the mantissa, we are looking at 2 things to do with the mantissa. We are looking at, we can increase the precision of the number. Essentially, we can store more decimal points after it, or it increases the accuracy of the number. Okay, again, for the exact same reason, because we have more decimal points that we can store. So we have reached kind of the end of our time this evening. We've kind of focused, we have focused mainly on web software looking at the 2023 paper. 2023 paper is publicly available on the SQA website, so you can go and have a look at the questions that we didn't look at tonight. Have a look at the web and the database section, which one applies to you.